Building built in 1929, Georgian Revival style building. It was slated in 2007. It was on the Providence Preservation's endangered projects list, and through the efforts of the design team, the city, Gilbane, Providence Preservation, and many other entities, it was saved, and here we are today. It's opening this fall as a historic green school. We worked closely with Providence Preservation as well as the Rhode Island Historic Commission, and the exterior is, the masonry is getting restored, and also the existing granite down low and limestone and terracotta up high is getting restored as well. Standard window glazing system, but what you see is a fiberglass mesh that's placed on the third surface of the glazing system, and that mesh helps with the daylighting within the classrooms. And the fiberglass is designed in a way that refracts the light in all different directions, thereby evenly distributing the light further into classrooms and more evenly. If you just had a translucent panel, it's essentially just going to stop some of the light. Light will continue on its path through. This bounces the light in all different directions, mainly the assistance of bouncing it vertically helps as it hits the ceiling and then gets further into the building. This also works in conjunction with the artificial lighting with daylight dimming controls. So as the sun brightens on the outside, the dimming sensor dims the light on the inside, thereby saving energy within the building. Some storage of these windows, you can see there's a 20,000-gallon rainwater collection system located in the back of the building. That, along with low-flow water fixtures, or toilet fixtures, and fixtures in general, help to reduce the overall water consumption by 60% within the building. So it's a very significant part of the water and sewer conservation. This stand of oak trees, very old oak trees on the south side, really has helped in the daylighting because it filters a lot of that sun coming in, as you can see on the windows, and doesn't allow as much heat gain to occur inside the space. The one great feature about the gymnasiums is that it's lit with a skylight in the center. One of the positives of that is we can get transferred light, borrowed light, from the gymnasium into the cafeteria, into the corridor below, and also if you take a look up high along the edge of the wall on this side of this gymnasium and on the opposite side of the other gymnasium, there are offices lined along each corridor, and they're using that borrowed light, natural daylight as well. Typical classroom, high performance. I talked about the daylighting, as we can see here, in conjunction with the high-end or energy efficient light fixtures, uplighting and downlighting with the daylight sensor. The induction style HVAC, high efficiency HVAC unit it's a pipe system, hot water pipe system. That provides, there's the main boiler or main air handling unit down in the lower level. That pumps air via ductwork to this induction unit system. That air, because of the design of the system, the air is supplied at a lower temperature, thereby reducing the temperature drop from all the way down the mechanical room to each of the classrooms. What it does instead is heat or temper the air within the unit. It's much more efficient doing it that way than to heat it down at the boiler room and pump the air through 200 feet of ductwork. The ceiling system itself has an NRC rating of 0.7, and actually I believe these are 0.8, these ceiling panels. The separation between each classroom for the requirements of acoustic separation, there's going to be gasketing on the wood doors. There's 2 layers of drywall on each side of the separation walls, as well as acoustical bad insulation in the center. There are some classrooms have a communicating door between the two. Those are acoustically rated doors, as well as having acoustical sealant or acoustical gasketing around the perimeter of those doors. One other reason that we went with the induction unit as well instead of say a VAV system was because of the acoustics and the ability to provide a larger volume of air at a less velocity reduces the acoustic background noise. The finishes in here, the paint, adhesives, all VOC, low VOC materials, recycled material with the drywall, with the VCT, the ceiling. I mean, you probably couldn't look at any material in here and say that it wasn't, at least a portion of it wasn't recycled. So as you can see inside these lobbies with the plaster moldings, the detailing, the frescoes above the doors on both sides of the lobby here, as well as on the interior face of the auditorium and within the auditorium itself. These were the showpieces in 1929, and what we're doing is restoring all of these spaces here. It includes bronze-plated doors, which are at the shop getting refinished. But all of that will get reconstructed as we move toward completion. That's a metal halide. And then there are also, you can see in the wires coming down in the center point, the intersection of the copper, there's sconces, pendant fixtures, chandeliers that are going to be hanging from those points. It was interesting when we arrived and looked at the space, the portico chandeliers was a wire with, it looked like a 5-gallon plastic drum cut out in the bottom with a fixture in it.